This video is on section 3-8 on the slopes of parallel and perpendicular lines. In our last section, on section 3-7, we looked at slopes, equations, and graphs, and reviewed some important ideas from Algebra 1. In this section, we are applying those ideas to, and seeing how those ideas are related to parallel and perpendicular lines. So by the end of this video, you should be able to determine if two lines are parallel, perpendicular, or neither when given a graph. And you also should be able to write the equation of a line parallel and perpendicular to a given line through a given point. We're also covering Geometry Standard G.4.1 that you know the relationship between lines in the coordinate plane and their equations. Now before I give you how parallel lines are related, I want to look at a Geometry Sketchpad file. These two lines, K and J, are parallel to each other. Okay, and I have written up here what the slopes of J and K are. Now as I move K, you'll notice that J will stay parallel, but more important than that, the slopes are always the same. Okay, so the slopes of parallel lines are always the same. And that will always happen for parallel lines. And I hope it makes sense that if two lines have the same slope, then they're parallel. Okay, the book puts it this way, that two non-vertical lines are parallel, then their slopes are equal. And also, if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. That's a biconditional. Okay. The way I look at it is if the slopes are the same, then the lines are parallel. Now let's see how that relates to. Let's kind of clarify that idea by looking at two examples. In example 1, I will find the slopes of line 1 and line 2 and see if they're the same. So I'll go from left to right. And the rise would be a +2, and the run would be a, let's see, 1, 2, 3, 4, 5, 6, 6. So the slope is the rise over the run, or 1/3. For line 2, again from left to right, the rise is 2, and the run is 1, 2, 3, 4, 5, 6. And the slope is 2/6, or 1/3. Now these slopes are the exact same, and because they're the same, these lines are parallel. Okay, let's try this one. In line 1, which is this one, line 1, I'll draw on this going from left to right. And my rise is a negative. I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, -9. And my run is a +2. And so my slope of this line is -9/2. In line 2, my rise is, I'm going down, so I'm going down 1, 2, 3, 4, 5, 6, 7, 8, -8, and my run is a +2. So the slope of this one is -8/2, which I could simplify, but it's easier for me to look at it right here and say that these two slopes are not the same, and so they're not parallel. Okay, write an equation of the line parallel to the given line that contains point C. Now, looking at this equation, it's in slope-intercept form. So you should be able to say that the slope is the number in front of x, or the slope is -5. Okay, so now using this slope and this point, I can write an equation in point-slope form, which again is y minus y1 is equal to mx minus x1. Y1, this is x1 and y1, so y1 is -2. So y minus a -2 is y plus 2 is equal to the slope, -5, x minus x1, which is 5. And I could simplify this and put it into slope intercept form if I wanted to, but it just asks for an equation, so I'll leave it in this form. Okay, let's do it again. Again, this is the equation of the line. The slope is the number in front of x, so slope is 2. And this is x1 and y1. The equation of my line is y minus y1 is equal to mx minus x1. Let's see here, y1 is the number 1, m is +2, x minus 8. Just plug things in. And this is the equation of my line in point slope form. Okay, let's move to perpendicular lines. And I will again show the Geometr Sketchpad file. Okay, now here lines J and K have been constructed to always be perpendicular. Okay, so if I move this, it'll stay perpendicular. Now the first thing you'll notice about the slopes, which are up here, is that they're not the same. Okay, and it's a decimal form, but if you multiply these slopes together, you would always get, let's see here, let's find an easy one. Okay, so 0.5 times -2, if you multiply these together, you get -1. Or if I made it so that they are 1 times -1 is -1. Or whatever these values are, 0.25 times -4 is -1. You'll notice that if you multiply the slopes together, you get -1. And that's what the book says. Two non-vertical lines are perpendicular, then the product of their slopes is -1. Or the other way, the converse, if the slopes of two lines have a product of -1, then the lines are perpendicular. Okay, also any horizontal line and a vertical line are also perpendicular to each other. Okay, now the way that I think about it is about negative reciprocals. Okay, it's another way to look at it, that if the slopes are negative reciprocals of each other, then the two lines are perpendicular, and also the converse of that is also true, that if two lines are perpendicular, then their slopes are negative reciprocals of each other. Okay, for example, in this case, m is 2/5, and this m is -5/2. So if I take this one and flip over the fraction, find the reciprocal, it'd be 5/2, and also it's a negative reciprocal, and so that's what I got here. Okay, that's the way I think of it. The book thinks of it as, well, if I take 2/5 and I multiply by -5/2, I get -10/10, which simplifies to be -1. And so these are perpendicular. Okay, either way you want to look at it is fine. Okay, let's use this for lines. Now, line 1. Okay, the rise of line 1 is a -3 because it's going down, and the run is a +3. And so the slope of line 1 is -3/3 or -1. In line 2, the rise is 1, 2, 3, 4, 5. And the run is 1, 2, 3, 4, 5, 6, 7. So the slope of this line is the rise over the run, or 5/7. Now, these slopes are not negative reciprocals of each other. So using my method, I'd say no, they're not perpendicular. Using the book's method, you would multiply them together. 5/7 times -1 is equal to a -5/7, which is not 1, and so these lines are not parallel. Sorry, not perpendicular. Okay, in this second problem, I'll first look at line 1. The rise is a -1, 2, 3, 4, 5, 6, 7, 8. And the run is a +1, 2, 3, 4. So this slope is the rise over the run, which I'll simplify to be -2/1. But it may be useful to leave it in that unreduced. Now the second one, I'll draw on this. The rise is a +3, and the run is a 1, 2, 3, 4, 5, 6. So this one, the slope is the rise over the run, or 1/2. Okay, so looking at this and this, I would say that yes, they're negative reciprocals of each other. So yes, they're perpendicular. The book would have you multiply them together, and you could do either the unreduced or the reduced. That 1/2 times -1/2, I'm sorry, or -2/1 is equal to -2/2 or -1. Okay, either way you look at it, yes, they are perpendicular. Okay, Question, which pair of slopes could represent perpendicular lines? Okay, you can either multiply them together or look at the negative reciprocals. And if you do this, if you multiply these together, you get 1, not negative 1. Okay, they're also not negative reciprocals of each other. Multiply these together, you get 2 over 8, which isn't 1. Multiply these together, you get negative 12 over 12, or negative 1, and so this would be the answer. You multiply these and you get 1/9. These are actually parallel. All right, let's apply this to equations of lines. And this equation is in slope-intercept form, and so the slope is the number in front of x, or -3. Now, before I find an equation of a line that is perpendicular, then I need to find the negative reciprocal of this slope. And I'll first think of -3 as -3 over 1. And so I'll flip it over and change the sign, and the slope of my line will have a slope of 1/3, a positive 1/3. Okay, so I'm use this slope and this point to write the equation of a line. And I will use y minus y1 is equal to m parenthesis x minus x1, where this is x1 and y1. And so I have y minus 2 is equal to the slope of the perpendicular line, 1/3 parenthesis x minus 6. And this is the equation of my line. Okay, one more example. The slope of this line is 1/2. But the slope of my perpendicular line will be the negative reciprocal of that. So I flip it over and change the sign, and I get m is equal to a negative 2 over 1, or negative 2. So I use this slope and this point, x1, y1. Y minus y1 is equal to m parenthesis x minus x1. Y minus a negative 3. So y minus a negative 3 is y plus 3 is equal to negative 2 parenthesis x minus 0. And I'll leave it just like this. All right, we were looking in this video about the slopes of parallel and perpendicular lines, how the slopes are related, and you should now be able to determine if two lines are parallel, perpendicular, or neither when you're given a graph. And also you can write the equation of the line parallel and perpendicular to a given line through a given point.